Scatter plots and lines of best fit. So we're going to look at all kinds of different things in this section. And some of it, you know, some of it connects things that you've already done, and we apply it here. Okay? So those are things you want to kind of keep in mind. So, what I'm about to put on the screen is going to be in your book. I'm going to show it to you in 3 parts. So if you want to wait until all 3 parts are up before you take a picture of the screen, you can do that. I've put the page number that it appears in your book so you can screenshot it from your book and make sure you've got a perfect picture to insert in your notes instead. That's up to you, okay? First thing. So this is an example of a scatter plot with positive correlation. And so what we're going to do is we're going to talk about correlation as it pertains to scatter plots. And we're going to talk about it in this way. How tightly bunched together are the points? 1. And are they moving, if they are bunched together, are they moving in a certain direction? So in this case, we notice here that there's a red line that's been placed on this scatter plot. That red line is known as a line of best fit. It best fits the data. Okay? Now if you notice from left to right, the points seem to be moving up. That's how we know that the slope of this line is positive. So we describe this particular scatter plot as having strong because the points are really tight on the line, positive because they move up from left to right, correlation. Okay? So if the line of best fit that you can put on your scatter plot moves up from left to right, hits a bunch of the points, and then the rest of the points are really bunched closely to that line, then we describe it as having strong positive correlation. Questions on that? Now, if the points are a little more spread out, but yet seem to be moving together, like this one, okay, from left to right the line goes down, which means the slope of that line is negative, we describe this as weak negative correlation because the points are a little more spread out. We've got some points that are really far away from the line. They're not bunched as tightly as they are over here. So we describe the correlation as weak because they move from left to right in a downward fashion. We describe it as negative. Okay. You can have a weak positive, you can have a strong negative. All right? It just depends on how closely the points are bunched together. Now, it is also possible that there's no correlation at all. The points are just a bunch of points spread out all over a grid, and you can't really fit a line to the scatter plot at all. And this would be an example where there's no correlation. The points don't seem to be moving in any particular direction, and for all intents and purposes, they're just a bunch of points on a graph, and we can't really make a conclusion about them. Okay. So whenever we describe a scatter plot, we have to use one of 2 different. Hello. So we use one of 2 different descriptors. So we either use strong or weak, positive or negative. That's what this is all saying. If there's a correlation, okay? If there's no correlation, we say no correlation. But if there's a correlation, we describe it as either strong or weak, and that's dependent on how closely the points are bunched toward the line of best fit, and if it's positive or negative based on the direction that the points seem to be moving. If they move up from left to right, we describe it as positive. If they move down from left to right, we describe it as negative. So you're going to use a combination of these words to describe the correlation unless there is no correlation. The type of problem that you're going to be working on in your homework. And this is on page 263 in your book if you want to screenshot it from there, or you can take a picture of the screen. And then once you get that in your notes, we'll talk about all the different things that you have to do here. We'll go through them together. What I want you to do is I want you to grab a grid because I want you to make a scatter plot with this data. The years are the independent variables. So that's your x-axis. The price. Now notice this is in the thousands of dollars. So this does not mean that a home costs $154.50. This means that a home costs $154,500. Okay? But you can use these numbers in the thousands as your y coordinates. Spread your points out enough. So make your scale spread out enough so that the points aren't all crammed in together. See if you can spread them out and kind of get a bigger picture view so you can try to determine the correlation. I'll talk about how to make the line of best fit. For now, just make the scatter plot. Do that now. Go. It's helpful if you actually label your points too. Put the coordinates of that point right next to it, because when we do the rest of this problem, it'll be easy to identify which point is which. Some decisions about your data. Does the data keep going up and up and up? I mean, it goes up by, $12,000, then it goes up by 15, then it goes up by 26. Does that seem like it's trending in the right direction? And in order to do that, you might need to kind of estimate what 6 would be and 7 and 8. Okay, I would say our prediction seems to be fairly accurate. Now, if it didn't fit this trend of the data, then you're more likely to say that it's not accurate. And if it's not accurate, in all likelihood, you didn't pick a best fit line that actually works with the data. So the better your best fit line is, the more accurate your prediction will be. Or you may be messed up when you made your equation. That could be the other issue. Okay. Questions on this? Yes.
How should we answer D? Do we need to write anything for it?
Well, you just talk about what I was just saying about how it seems like the numbers keep going up, and they keep going up over a certain period of time. It fits on my best fit line, and use all those kinds of things to describe it. Okay. Most of the time, it's going to be a situation where right away you're going to know this doesn't make sense. This number doesn't make sense with the rest of this data. So either I messed up with the best fit line, or my calculation for the equation was wrong. Okay. But most of the time, it's going to be fairly accurate. Yeah.
Are we going to need to memorize anything about it, or just without question? How we gotta
Just the idea that you have to write down the 2 points that you chose. Okay. So here's what your graph should sort of look like. Okay. Obviously, depending on the scale that you used, it might look a little different. But one of the things that we can identify before we even put the line on is the direction the points seem to be moving. First of all, is there correlation here?
Yes.
Okay. Is it positive or negative?
Positive.
Positive. It's definitely moving up from left to right. So we can describe it as positive correlation for sure. We can't determine strong or weak until we put our line of best fit on our graph. Now, here's the thing that I need to make clear. And when we get to a test, you're going to need to make this clear as well. Your line of best fit could be different from the person next to you. There's an actual exact line of best fit. It's called the regression line, but we're not doing that in this chapter. We're basing it off of your opinion. Now, there are wrong answers. Let's keep that in mind. If I tried to draw a line of best fit, and I said, okay, here it is. There's my line of best fit. That really fits all. That's clearly wrong. The points are not moving in that direction. That would not be a correct answer. Okay, so we wouldn't want to do that. But there are going to be variations on what could be right. Here's the key thing you got to keep in mind when you draw your line of best fit. Make sure that it hits at least 2 of the points. Make sure that your line of best fits hits at least 2 of the points. And if possible, see if you can make it hit the y-intercept if you have the y-intercept. You're not always going to have the y-intercept. And if you don't, just make sure it hits 2 points. So, here's the line I'm going to draw. And see if I can make this work. Because I want it to kind of come up this way, right? So that's not bad. Now, if you notice, we have this point up here that seems to be kind of really far away from the line. But there's only one of those like that. And even though I have 2 points down here that aren't on the line, those two together, their difference, the distance, might make up for this one distance. So I'm pretty satisfied with this line right here for me. And I actually got it to hit 3 points. Okay. Your line might look a little different than that, and that's okay. Make sure it hits at least 2 points. If possible, make it hit the y-intercept. Does my line hit the y-intercept?
Yeah.
Yeah, it does. It hits it right here. Okay? I'm going to explain why it's nice. It's not important that it hits the y-intercept. It's just nice when it hits the y-intercept, because we're going to do that in a second. Now, I have 2 options for the other point. I've got this point 3,207 or 4,228.7. I feel like this point is more on the line than this one, so I'm going to use that point. Okay. So let's finish the rest of the correlation. Strong or weak? Strong. I mean, I've got 3 points on the line, and I got 2 that are really, really close. Okay, so this is definitely strong, positive correlation. Again, remember, strong or weak, positive, negative, if there's a correlation. So I answered that part. I put my line of best fit on there. I have my scatter plot, so I've answered part A. Okay, part B says write a prediction equation, I believe. Is that what it says? Okay, so what that means is I need to write an equation for this line. Because this line of best fit, the equation for that line is the prediction equation. Okay? And to come up with that prediction equation, you just need to use 2 points. Because we know if you have 2 points, you can write an equation. So now we're back into 2-4. We're applying what we did in 2-4 to something sort of new. Here's what's important, because on a test, it's possible that Matthew uses 2 points for his line of best fit, and Jay Henry uses 2 different points, and they both could be right. So what's going to be really important on a test and in your homework is that you identify which 2 points you've chosen. Now, on my graph, I circled those 2 points, but I'm asking you to write them down. Write down the 2 points that you've chosen, because I might have to have 4 different answer keys for a particular problem and find out how you calculated the slope and how you found the y-intercept for this one, and then somebody else who has another line of best fit that's still right but different than yours will end up with a different slope and a different y-intercept. Okay? So if you identify the points that you use, then I can tell if you use them correctly. Does that make sense? Okay. Now, of course, once I have 2 points, I can write an equation. So, what do I need to find first? Slope. Okay? So, what I want you to do is do that. Find the equation. You got 2 points. Find the equation from those 2 points. Go. What 2 things do we need in order to write an equation?
2 points.
Slope and the y-intercept. So, when you're finding the slope, this is the advantage to choosing the y-intercept as one of my points. Because now I don't actually have to solve for the y-intercept. Now, keep this in mind. It's not always going to be the best point to use. It's not going to fit on your line. But if it happens to, use it, right? That's going to save you a little bit of work. Because now instead of having to plug one of the points that I chose into my equation to solve for the y-intercept, I can just pick it off. Because in this case, B is 154.5. But again, keep in mind, it's not always going to work out that nice. Okay? But if it does, use it to your advantage. Make sure that line of best fit, it still needs to be the best line. And if that means it doesn't hit the y-intercept, then that's what it means. And you're going to have to come up with a different value there. All right? How many of you need more time to finish the equation. All right, take another 15, 20 seconds. So here's what your work should have looked like. Now this problem was all in decimals to begin with, so my slope should be in a decimal form. So you could have made it 18.6, that would have been fine. Now normally, if one of the points was not the y-intercept, at this place right here, I'd have to plug the x and y in and solve for b. But because I was able to use the y-intercept as one of my points, I can just plug that in here.
Wait, I have a question. What if you use different points?
That's fine. You're going to get a different answer because your line is different than mine. And that's what I was saying about on the test. It's possible there's more than one right answer. Now, a couple things you need to look out for, right? We already said this had a strong positive correlation. If you end up with a really small number here or a negative number here, you messed up. Strong positive should be a positive slope. Okay? Now, this is the prediction equation. And what we can do with it is answer part C. Because they want us to know, all right, what's the price of a house going to sell for in 8 years? Because the table only went up to 5 years. So how am I going to figure that out? Plug 8 into x. So do that. Okay? So now use your equation. The equation of the line is the prediction equation. And to find the mean selling price of a home in year 8, do that now. Another thing to keep in mind, we're talking about a word problem here. Make sure that your answer reflects the actual problem. Make sure that your final answer makes sense. Okay? We're talking about the price of a home. Make sure that your final answer makes sense for this problem. One of the things you have to remember was that the price of the home was given to us in thousands, right? So none of the houses cost $150. So yes, if you got $290, that's not how much the house costs. It's $290,000. So your final answer should reflect that. Now, so this house, the median price of the house was not $302.9, $300. That's not what it is. It's $302,000. Okay, so your final answer should reflect that. Okay, so if you look here, I have to take it another step. Well, y is 302.9 for the 2 points that we use. That is not the price of a house. There are not houses, as far as I know, you can't buy a house for $302.90. If that were the case, there would not be homeless people. Okay, everyone would have a home to live in, right? They're talking about a home that's $302,900. So my final answer should reflect that. Put it back into its context. Okay, now, the last thing Part D asks is this accurate? Okay, and to answer that question, is it accurate, you have to